Hi, we are going to start the third topic of this chapter, that is topic number 3, 4.3, and the name of the topic is Biot-Savart law. Biot-Savart law is the name of the topic. Okay, so this Biot-Savart law, this basically explain about what is going to be a magnetic field due to a current carrying element. I repeat, current carrying element. So what it's going to tell about is, see, let this be a current carrying element. Okay, this is A and this is B. Current is traveling from A to B like this, and let I be the current flowing through the this wire. I ampere current is flowing through this wire. Fine. Now let this be a small segment whose length is dl. dl is the length, and I am marking it as dl vector. And you must not miss one thing over here. The direction of dl vector is exactly the same as that of the current flowing. Alright, now let this be the point P, and the position vector of point P is r vector. So this point P, we need to calculate the magnetic field due to this small segment dl, this small segment dl at point P. This is what we are going to do, and Biot-Savart law will explain what is the magnetic field due to this dl segment at P. So before that, I need to explain one more thing. So here you can see there is an angle. So let this angle be theta. So theta is the angle between dl vector and r vector. Okay, so here, since this small segment, since the magnetic field is going to be calculated just because of this small segment dl, so I would like to mark the magnetic field at this particular point as, see, I had just created a cross sign over here, and the magnetic field is db vector, and here it is a cross sign. Okay, so why it is a cross sign there, that I will explain here. See, let this be your thumb. Okay, and and let this be your curl fingers. So it can't be that a perfect diagram. So you just assume that you are holding a wire that is carrying a current of I ampere. It's carrying a current I ampere, and you must not miss this. The direction of thumb and the direction of current is the same. You can see that this is the direction of the curl fingers, isn't it? See, this is the direction of curl fingers. So if thumb indicates the direction of current, then this direction of curl fingers, that will give the direction of magnetic field. Okay, that means if this is the wire, and let this be the direction of current. Okay, like this. So the direction of magnetic field is going to be like this. So if we take two part, like I am going to consider one plane here. So here for this particular plane, this line is moving away. So once it is moving away, that means it's cross. And if I consider a plane here it is coming towards you, that means it's a dot. Okay, so for this particular current carrying wire, on the right hand side the direction of magnetic field is away from you, and here it is towards you. So that is why we are having the cross line over here, because here the current is moving from A to B, similar to that of this one. On the right hand side it is cross, and on the left hand side it should be dot, but it's not required here. So it should have been a dot here, and here it is a cross value. Okay, now according to Biot-Savart law, the magnet of this small magnetic field dB vector's magnitude, that is directly proportional to the current passing through the wire. Second statement, the magnitude of magnetic field is directly proportional to the length of the segment, that is dl. Then the magnetic field's magnitude is directly proportional to sine theta, and the magnitude of the small magnetic field is inversely proportional to the square of distance of separation. So these three statements, statement number A, statement number B, statement number C, and statement number D, all these four statements altogether is known as Biot-Savart law. Okay, so once we do combine these four statements, we can write like this: dB proportional to I dl sine theta by r square. Okay, the proportionality sign is removed by inserting a proportionality constant, that is mu naught by 4 pi I dl sine theta by r square. So what's the proportionality sign has been removed, it's going to be replaced. We can have this proportionality constant over here, that is mu naught by 4 pi. So this, the value of this proportionality constant, that is mu naught by 4 pi, that is 10 to power minus 7. That's the value. And this mu naught, this is known as absolute permeability of air or vacuum. That's what this proportionality sign, that is this mu naught do stands for, absolute permeability of air or vacuum. Okay, and if it is some other medium, like other than air or vacuum, then this particular equation is going to be like dB equal to mu by 4 pi I dl sine theta by r square. So this is actually the vector form. Okay, so if we do want to have this, this is the scalar form. If we want to have the vector form of the same, then obviously, see here this is dl vector, so here this is dl vector. So I'm coming to the vector form of this one, and here this is r vector. Okay, so you know that dl cross r, it will be away from you. Fine, dl cross r is going to be away from you, and r cross dl is going to be towards you. Like is going something like this. So here this is dl, fine, dl vector, and here this is r vector. So this is going to be the direction of dl cross r, fine, and here this is going to be the direction of r cross dl. And from this diagram it's very clear that the magnetic field is pointing away from you, that means it's in this direction of dl cross r, fine. So while representing the vector form, db vector, it's going to be mu naught by 4 pi, isn't it, I into dl cross r upon r cube, fine. Why this r cube over here? It is that in this case you know that there is no r component over here, but just to have the direction we had this dl cross r. So one, obviously the magnitude will change, so to compensate with the change in magnitude only we are having r cube over here. So that was Biot-Savart law, that is topic number 4.3. All right.